So today we are going to solve the problem is subsequence. We are going to solve this problem is subsequence, and the solving approach would be I will be using AI to ask me questions. That is, AI will be my interviewer which will be asking me right questions and guiding me to the answers. But it will not give me either the code or any algorithms or direct answers. I will have to figure that out and then at last complete the code part. So today we are going to do is subsequence. Let us click on that. So this is the problem statement. Given two strings s and t, return true if s is a subsequence of t or false otherwise. Example is s is abc and t is equal to ahbgdc. Having a close look at t, s is indeed a substring of t. That is, t has a, b and c. Now these characters make up the string s, which is abc. Let us take a look at example 2. Here we have axc as s and t does not have x. Hence, s is not a substring of ahbgdc. Thus the output is false. Let me copy this. I'll be using Claude code. Having a look at Claude code, I have named this to be Socratic interviewer. You are my Socratic coding interviewer for live, unedited problem solving ideas. How do I ensure that AI does not give me the answers? For that, here we have the instructions part. If I take on edit, here I have given all the instructions, which says the first instruction is do not provide the solution code unless I explicitly ask after the session is over. Do not reveal the full algorithm immediately. Ask guiding questions that help me discover the approach myself. Likewise, I have added around 13 instructions, which makes sure that Claude code is not giving me the answers, but indeed helping me to refine my thinking and come to the conclusion. Let me paste that question and then hit on OK. Before that, I'll tell to the AI what I think about the solution or the approach. As I am using JavaScript for solving these problems, the straight forward answer would be to use substr function, which is already present for string data type. Apart from this, I can use the brute force approach in which I will traverse the string with maximum length and check the string with minimum length is contained in the largest string or not. In the second approach, the time complexity will be big O of n square, which we do not want. Hence, the first approach is ideal in my opinion. What do you think of the above? Now what Claude will do, Claude will take into consideration the instructions, and based on what I am proposing a solution now, it will ask me questions. Hit enter. Good start. You are thinking out loud, which is exactly what interviewers want to see. But let's slow down and pressure test your thinking before we go anywhere near code. You mentioned substr as the straightforward answer. Can you tell me precisely what substring does and why you think it solves the subsequence problem? What substring does? So for that, let me open a new tab, JavaScript string method. So I click on this MDN web docs. This feature is no longer recommended, though some browsers might still support it. Here it is. The substr method of string values returns a portion of the string starting at a specified index and extending for a given number of characters afterwards. Okay, example is Mozilla. Okay, string substring. Okay, oh, I think I have missed out something. So when I say substring, so it accepts the starting index and the ending index, and then from the given string it will return the values starting from this index and going up to this index. So in this case, here we are saying start from index 1, which is O, and then go up till index 2, which is Z. Hence the expected output is OZ. So I don't think we can directly use substr. Okay, what does it? So therefore people are advised to use standard substring and slice method instead to make their code maximally cross-platform friendly. So we have substring. Okay, my bad. Let us go to the interviewer and say, got it. The substring method takes in the starting index and the ending index, and accordingly will return, takes in the starting index and the ending index, and accordingly will return the specific part of the main string. Example, main string is equal to, say, John Doe, and if we do const first name equal to main string start from 0 go up till 3, so first name to be equal to John. My bad, cannot directly use substr. Okay, so we cannot use substr. You caught yourself. That's exactly the kind of self-correction that builds good instincts. So now that substr is off the table, let's revisit your brute force idea. You said you would traverse the longest tree and check if the shortest tree is contained in it. But what does contained mean for a subsequence specifically? Think about this. Ace is a subsequence of A, B, C, D, E, but they are not adjacent characters. How does that change your traversal strategy? Okay, so let's say S is equal to, I'll use VS Code. Let us see S is equal to Ace, and T is equal to A, B, C, D, A, B, C, D. So here, as per the approach I said, we are going to check whether T contains S. So for that, First we will identify the string. First we will identify the string having the largest length. How can we do that? How can we do that? Okay, let is s. There's no need to identify because in the problem statement itself, we have to check. In the problem statement itself, we have to check whether s is a subsequence of t. Hence, no need to find out the largest string. What we can do for let I equal to 0, then I less than t dot length, then I plus plus, and here we will use for let j equal to 0, then j less than s dot length, then do j plus plus, and then we do if t of I is equal to s of j, t of I is equal to s of j. We also use a variable let s is equal to d, let t we'll also use a variable count. We will initialize that to 0, and here we will increment the count. After incrementing, we will check if count is equal to s dot length, then we will break out of this loop, right? Then we will break out of this loop. So we are going to start. So t is a b c d e and s is e c e. So first we will check t of I, which is a, is that equal to s of j? Yes. We increment the count. Count is now 1. And after that we say if count is equal to s dot length. No. Count is 1 and s dot length is 3. So it will not break. But ideally we should click on we should add a continue statement here, because this will instruct the code to again start to begin from the front, to begin the loop execution from the start. So, but if we add continue over here, then this statement will never reach. So I don't think so we can add continue here. Let us traverse this. P of I is a, s of j is a, count is 1, then j will be 1, c, and we are going to check if t of I double equal to, no, it is not the case, but if t of pi is equal to s of j, in that case, after incrementing the count, I think we should come out of the loop. Yes, this statement should be written out of the if. Here we'll add a break. So what this will do is, first it will check a s of j is equal to t of I. Good, count is will be incremented to 1, then it will break. That means the execution of this for loop will break. On the state, it should come out of the for loop. For the execution of the for loop, to come out of the execution of the for loop, then I will be incremented to 1. Now I will be b. Then we are going to check if s or s has b. No, this condition will never be executed. Again, then it will be c. Third part, okay, s of I will be c. So does s contain c? Yes. Now the count will be 2. Then at last we have e. So here we have e. So the count will be 3. And when count is 3, Let me remove this. After both the for loops end, I check if count is equal to s dot length, then return true. If that is not the case, return false. Let's mine approach and answer for the above question. I can see you're jumping straight to code, but you are not there yet. Let's pause. Before I look at the code, I want to ask you something critical about its logic. Consider this case: s is equal to ab, t is equal to ba. Your code has a count variable that increments whenever any character of t matches any character of s. Okay, walk me through what your code does with this specific example. S is equal to ab, t is equal to ba. S is equal to ab, t is equal to ba. So, code walkthrough. I is 0 and j is 0. When I is 0, in that case, t of 0 is equal to s of 0. Now t of 0 is a and s of 0 is b. No, that is not the case. So count will stay at 0. Then j count will stay at 0. J will be equal to 1. Again, we will check t of 0 is that equal to s of j, which is 1. So t of 0 is k, and so t of 0 is still b, and s of 1 is b. Now in this case, count equal to 1 and j equal to 2. If for loop exits. After that, okay. So in this case, count will be 1, and then I will become 1. When I is 1, we are going to check t of 1 is that equal to s of 0, since this loop will be again started from 0. Count is already at 1, so t of 1 is a and s of 0 is a. So yes, count will be incremented to 2 and j will now become 1. After this, we are going to compare t of 1 with s of 1. T of 1 is a and s of 1 is b. So count will stay at 2. Now j becomes 2. Beginner for loop exits. And after coming out of the for loop, the count is now equal to s dot length. So the function after the end of the for loop, the count, the if block will be executed and it will match 2 and the function will return 2. Let us give this to pure code. Exactly. And is AB actually a subsequence of BA? Yes, it is, right? Yes, it is. Yes, it is. If a sequence or occurrence of characters do not hold a priority. Okay, that's the key misunderstanding to fix right here. Subsequence absolutely cares about order. Go back and reread the problem definition. AB is not a subsequence of BA because A must appear before B in T and in BA it doesn't. Okay, so your current approach is flawed because it counts matches without caring about order. Here's my question. What data structure or technique could you use to ensure you're matching characters of S in order against T? What data structure or technique could you use to ensure you're matching characters of S in order against T? Set data structure. I'm not sure though. Not quite. A set stores unique values and doesn't help with ordering or position tracking. Let me give you a small hint. You don't need any fancy data structure here. What if you only had one pointer for S and you moved through T one character at a time? What would that pointer represent and when would you move it? Think about this. What if you only had one pointer for S? What if you only had one pointer for S and you moved through T one character at a time? What would that pointer represent? Okay. Data structure be array. If I had only one pointer for S and I moved through B one char at a time, that pointer would represent what would that pointer represent and when would you move it? If I had only one pointer for S and I moved through T one character at a time, that pointer would represent char of S. A single char of S and will be moved if and only if it matches the char from T. Okay. If I had only one pointer, data structure would be array. If I had only one pointer for S and I moved through T one char at a time, that pointer would represent a single char of S and will be moved if and only if it matches a char from T. When do you know you have successfully found all characters of S in order and when do you know it's impossible? When do you know you have successfully found all characters of S in order? All characters of S in order. Okay. Okay. So if I have reversed it about two for loops such that the outer loop will iterate the chars of S and the inner loop will iterate the chars of T. In that, solve it Or am I getting confused here? Okay, the pointer moves through S only when it finds a match in T. Do you even need a second move, or can you handle S with just that single pointer? Why you loop through T at once? Okay. You are getting Warner, but two nested loops is still big off and squared. You are also drifting away from the one pointer insight we just had. You said it yourself, the pointer moves through S only when it finds a match in T. So ask yourself, do you even need a second loop? Or can you handle S with just that single pointer while you loop through T? So if S pointer is equal to 0, and while I am looping through T, I check S of that pointer. Okay, got it. One autocorrect. Got it. So S pointer, we start from 0, then for the for loop, which will iterate B, and here we will check if T of I is equal to S of S pointer. If T of I is equal to S of S pointer, then we increment S pointer by 1. Here we click on continue. And at last we check if S pointer is equal to hash dot length minus 1, return true, else return false. This will solve. Okay, great progress. You got the core idea right, but there are two bugs in this code. Look carefully at your final condition. If S is equal to ABC and to successfully match all three characters, what will S pointer be when the loop ends? And does S dot length? Okay, got it. So S pointer will be 3. S dot length minus 1 will be 2. Sure, I am mixing array indices with array indices logic of starting from 0. Okay, exactly fix that first. So instead of that, here I use test dot length. That is fixed. Now there's a second bug. Think about edge cases. What happens when S is an empty string? What does your code return for that? And is that correct? Okay. If S is an empty string, in that case, it will always return true, which is no. Yep. That should not be the case. I think the code handles it. The fixing the above issue, I gave the code handles the second bug automatically. How? if s coiter is equal to s dot length. The code does not handle it because s dot length will be 0 and s pointer is also 0. S is an empty. So if we had to add a condition that would check S is not empty and only then progress with the code implementation. Else return false. Deleting some can be none. A subsequence of a string is a new string that is formed from the original string by deleting some can be none of the characters without disturbing the relative position of the remaining characters. Okay. Okay. So So does your current code actually handle that correctly already without any extra condition traced through it? Yes, it does. Because after changing the final if block from if s greater equal to s dot length minus 1 return to if s greater dot length return in case of empty string else pointer will always be 0 and s dot length will be 0. Hence, it will return true. Okay, one more edge case before I let you write the final version. What happens when D is an empty string and S is not empty? When D is an empty string, okay, D is an empty string, so this for loop will never execute because I is 0 and I is less than T dot length. If you come here, S pointer is 0, S dot length, let us say it is 3, 0. In the code you return false because the for loop for D will never execute and the if condition of S vector is equal to S part length will evaluate if false and the returned answer would be false. Okay, only the return. The will test. So here it is the final version. My bad. That is pointer equal to Z. correctness. The logic is correct. The pointer approach properly respects orders and handles empty strings, empty t and normal cases. It got empty s and empty t during our walkthrough. Code time complexity, space complexity, code readability. The continuous statement is unnecessary. If the if block only has one action and there's no else, the loop naturally continues anyways. It adds noise without value. Okay. S pointer is fine, but I is a bit generic. Something like T index would make the intent clearer for a reader. Interview communication, you jumped to code before fully articulating your approach. Verbally, in a real interview, always say your approach out loud and get the interviewer's buy-in before typing a single character. Before I give your score, tell me the time and space complexity of a solution. Let me remove the continuous statement as it is creating nonce. So this is removed, and time complexity will be, since we are iterating over the length of string t, so time complexity depends on the length of the string t, which will be big O of n, and space complexity irrespective. Okay, just to that, coming back to LeetCode, so we have the coding option s and t. So s and t are already passed. Space complexity will be big O of 1, which we are using to store s pointer. In complexity big O n, since we are iterating string e till n minus 1, space complexity will be big O of 1, e echo of 1 for storing variable s pointer. And here is the final version of the code. Let us go to LeetCode, where is subsequence. So we will declare a variable s pointer that will start from 0. They'll iterate through string t and check if s is a subsequence for let t index is equal to 0 and t index is less than p dot length t index plus plus. Here we will do if s of s pointer is equal to t of t index and increment the s pointer, and after the end of the for loop check if s pointer is equal to s dot length, then return. For readability, let me add opening and closing curly braces, return true. If that is not the case, then return false. Let me give this to Claude. Core for LeetCode copy. Okay. Complexity is correct. Correctness handles all cases properly. Readability much cleaner than your first version. Good variable names, good command. One minor thing, your final if return block can be simplified to a single line. Got it, done. Yes. So let me change that. Turn this. This is good. Okay, you got there, but it took pressure to surface the ordering flaw in your first approach in an interview. That bug would have cost you significantly if I hadn't groped it. What clues did you miss? The word relative positions in the problem statement is a direct hint that order matters. He initially dismissed ordering entirely. What pattern should you have recognized? This is a classic two-pointer problem. Anytime you are matching elements from one sequence against another in order, two pointers should come to mind immediately. What would an interviewer think? They'd appreciate your self-correction and coachability, but jumping to code before verbalizing the approach and the initial ordering blind spot would raise concerns about problem reading habits. What would you do differently next time? Read the problem statement word by word, underline key constraints like relative positions before writing a single line of code. One concrete improvement for next time: before coding, spend 60 seconds saying your full approach out loud, input, output, edge cases, and algorithm before touching the keyboard. Perfect. Now let me run this code. So both the test cases are. Let me submit this. And here it is. The code has been accepted. I have, you say, one analysis left. I'll run that. So we'll analyze the code for approach, efficiency, and code style. Okay, current is two pointers or greedy. Using a greedy two-pointer approach to verify character order preservation in linear time. You have done that. Complexity, yes, big O of M. Code style, readability, structure, suggestions. So yes, I have used Claude Code or AI. I have used Claude Code or AI as a Socratic interviewer and have helped it to guide me to the correct solution without ever asking the AI to give me the code. So thank you all.